Hello, everyone. Welcome to today's developer coaching webinar. My name is Tara Van Cleve, and I am part of the database organization here at Oracle. Today, we're excited to show you a live demo on how easy it is to switch a real existing application and its data from MongoDB to Oracle and enable GenAI-driven capabilities directly using the JSON data and AI features to expand your application with new capabilities. And today's webinar will be presented by Beta Hammerschmidt, VP of Oracle Database, SQL, and Analytics, and Nacho Martinez, Data Scientist Advocate. So without further ado, I will hand it off to Beta first. Beta, take it away.
Thanks a lot, Tara. So this is actually part two of an interesting series. Last week, we showed the migration of an application. And this was an application we didn't build for the purpose of migration. It was actually like a community application, and it used the MERN stack. So MERN stands for Mongo, Express, React, Node. And what we did in a few minutes or even seconds, we moved it from MongoDB to Oracle. So we replaced the M with an O. All the rest stays the same. Like we didn't have to change Express, React, or Node. It just like MERN sounds better than ORN. So we have to coin a better term there. It doesn't, it's not, I mean, if you attended last week, it's great. You know what we talk about, but I think you don't need to know what we did last time. We will do like a recap, and you will also see in this demo, you will see how we migrated it earlier. The idea is that we replace the data storage from MongoDB with JSON collections in Oracle database. And this allows us to do all the nice things that MongoDB can do, but also a lot more things. Let's say SQL, analytics, reporting, joining with relational table, etc. And one of the aspects we will see today is the AI capabilities of Oracle database. And the way we achieve really this easy lift and shift or switching from MongoDB to Oracle is that we understand their wire protocol. So you don't have to rewrite your application. You can just replace the connect string and have your apps or your driver or your framework or your tool like Compass point at an Oracle database instead of a MongoDB server. So why do we do that? First of all, we see a lot of application developers that want to get a bit more out of their database, and they don't want to keep a MongoDB and, let's say, a relational database in sync. They may have like some OLTP use case in JSON, but then they have some reporting use case, etc. So we can do all that in one database, while at the same time allowing a MongoDB developer to keep using their skills, their knowledge. They don't have to write different queries if they don't want to. They can use SQL, but they don't have to. They can use any tool they want, Compass, Studio 3T, etc. Drivers, frameworks, Spring for MongoDB, for example, this all works. So it's kind of you stay in your comfort zone, while at the same time, if you store your data in Oracle database, this now opens things for a lot more things. SQL, BI tool, analytics, high availability, etc., all this stuff. So we have also a cloud service called Autonomous JSON Database. This is a managed service which has this MongoDB compatibility, and that makes it really easy to get started. Another nice aspect is that it also allows you to lower your costs. So we see quite some effective cost savings by moving from MongoDB to Oracle. I know a lot of developers, this may not be the biggest selling point, but whoever foots the bill in an organization might find that very interesting, that they can continue doing the same development work and cut their bill in half. Migrations can be done easily. We've seen that last time just by running like a MongoDB export or dump and a MongoDB import or restore. And we also have a visual tool. It's a Golden Gate container, which allows you to make these migrations simpler, especially if you have large amounts of data or if you want to do a zero downtime migration, like if you want to do cut over from a MongoDB to an Oracle, while all your apps are up and running and your customers wouldn't really know that the backend database has changed. So we have all these abilities. Lots of customers are using it. Not everyone does zero downtime. Most people are fine with a little bit of downtime after they move the data, replacing the connect string. But this is kind of the recap, what we did last time. Today, we want to look at another capability that we have in Oracle database and that works with JSON data. And these are the AI capabilities. So This is another nice thing about Oracle that we probably don't give enough credits to is we have all these nice capabilities, but these are not separate silos. There is not like a JSON silo and an AI silo and let's say a relation silo. All these capabilities are meant to work with each other. Like you can um, use JSON with AI, and then you can do, I don't know, some reporting on top of that. So it's kind of a system. Like you could think of many different Lego parts, and you can assemble them the way that suits your use case best. So in the past, I give a little introduction here into AI workloads. I mean, most of you are probably familiar with it, but some of you may not. So let me just give you a little introduction before Nacho does a deep dive into actual code. So in the past, for the last, I don't know, 30, 40 years, databases were primarily looking at fields and strings and numbers and dates that were stored in records. And the record could have been like a relational row format, or it could be like a field value in a JSON. And a query would have been, for example, like find me a document or all the documents for a customer in that zip code. Or you could have analytical queries where you say aggregate the revenue by product. But you were basically using the database to compare or to filter values based on numbers, strings, and dates. And these would be like range queries or equality queries. Um, since a long time, there is a lot of growth in data that is not entirely structured. So there's a lot of like social media data, videos, there's like PDFs, there's Word documents, etc. And often you want to look for things that are kind of similar or search based on semantics. So you may say, hey, I want to look at all the images that look like this image or all the images that contain something, for example. So this is not looking at pixels of an image or words in a document. It's really more about semantic or similarity. So the example we could use here is we have a lot of different documents, let's say about a bike. We have a PDF that describes a bike or that may contain a picture about a bike. We may have photos, images about bikes. We may have a video where in one scene a bike occurs. And if we have all these different media, and we want to find like give me all the documents that say something about bikes or a red bike or a fast bike, then we need something that's called AI vector search. So you may have heard this term quite a lot. It's actually often it sounds complex. Like when this started, I really thought there's must be like some it's really complex, and it actually isn't. So what you have is you describe objects with a vector, and it's literally like a vector, like in math. It's an array of numbers. So here in this example, we have a vector of 5 numbers. It's usually a lot bigger, like 100 times bigger, or even bigger than that. And this vector is giving numbers to characteristics. So in a very simplified version, you could say, hey, there's one position that describes the color of the bike or the size, or if someone sits on top of not. It's not as easy. These vectors are built by embedding models. They're being trained. I'm not going a lot into detail, but what I want you to understand here is just that we describe an object just with a large list of numbers. These numbers are stored in the database. They can be indexed for fast access. And I came up with like a little example here. Let's say we had a JSON document, and this document has some data inside. And one of the fields here, I didn't put like an image in here because I put a URL that points to an image or two images, actually, like an image of the rider and an image of the bike. And you could say, hey, I want a vector that describes this image. And that's the other field there that you see with underscore vector. And this vector could already be embedded in that document when you insert it. I think this is what MongoDB asked their developers to build the vectors outside. We can actually even build these vectors inside the database. So you could insert a JSON document without any vectors, but then the database would vectorize the fields that you want to use for semantic search or for similarity search. And these could be like text strings. Like I think the most common thing are kind of texts. If you have like movie documents and there's a plot, etc., or these could be images or things you point to in a URL. And then once you have all your data being vectorized, then your search is also vectorized. And then you do a similarity search. So you almost never, I think I would say not, like you would never look for equivalent vectors. These are usually float numbers. So probably no two vectors are exactly the same. But if you have two vectors, you can calculate the distance. And it's really like if you remember high school, two vectors in an n-dimensional vector space. Yes, there is like some formula and you calculate the distance. And then you say, well, things that are kind of close together, those are similar, and things that are very far apart in that vector space, they're not similar at all. So in almost every case, there's also like some scoring or an order by where you say, I want the results ordered by the distance. And I think those are the concepts. And with this, I would like to give it to Nacho to show now very hands-on and practical how he applied these capabilities or these new AI features with the application that we switched from MongoDB to Oracle last time. Over to you, Nacho.
Yeah, thank you. What I would like to add to your introduction to MERN is to, that this session I wanted to be practical, but as well keeping it simple with the concepts that we're going to see, because there are a lot of them. So if you have any questions, we have the Q&A that you can ask questions in the meantime. But I want this to be more of a developer-focused session than last week, right? We do have the MERN e-commerce application working here, right? Just like last week, the functionalities of the application are working. If some of you were already here, we did create some test brands. We are currently connected to Autonomous, so we already performed a migration between or from MongoDB to Oracle Autonomous 23AI for all the reasons that Beta has said. And now that the application is working, my idea was, okay, since we're using a kind of microservice-based architecture, and I'll explain why, it's very easy to develop, applications. And since I'm a data scientist, I said, well, let's create something around artificial intelligence so that we can expand the original functionality of the e-commerce app, right? So this that I'm showing you is a guide that we have not published yet, but you will get access at some point to it when we publish it on GitHub. But this will serve as an introduction and, as some guideline of what we will see today, right? So just as a brief introduction for MERN, since we are now working Oracle, it should be ORN, but the stack, the applications that we are using is Oracle, of course, Oracle 23i with vector capabilities as a storage system. Then we do have Node.js as the backend, the JavaScript runtime environment. We also have another framework from Node called Express that will allow us to create this kind of microservice architecture where we want to implement a specific feature. We can just create a new endpoint and implement everything that we want inside that endpoint without interfering with the other systems of the application. So it's a very modular way of programming. And finally, for the front end, we do have React. So everything that you'll see here, which is this very easy LLM chat that we create on the app, is using React, right? So why is it important? Well, first of all, we are putting AI and the other parts of the application separately. And the data is already migrated and accessible. So all the JSON collections that we do have on Oracle 23ai, because of what we do have enabled there, some functions for vector search and all these AI helpers that Beta was mentioning, all the JSON collections are already ready to be embedded inside the database very easily. And it's a great foundation. It sets a foundation on this microservices architecture to add some AI capabilities without disrupting the existing functionality of the application, right? So I'm a Python guy. I'm not so much a Node.js guy. So the good thing about microservices is that I can just use my own programming language to implement the features that I want. And if there were, 10, 25 people working on this specific problem or this project, each person could use their preferred, programming language, techniques, frameworks, and just implement everything in this kind of like a microservices way, which defeats the what was usually done before, which was kind of like a waterfall method or a cascade method, where you had to wait to implement before you had to do some very rigid task that couldn't let you start implementing, and you had to communicate and have lots and lots of syncs with the other developers, which is kind of counterproductive. So this kind of microservices method of developing was developed. So we will be implementing a RAG system, which stands for Retrieval Augmented Generations. And what this is going to allow us to do is to not only get answers in natural language, but also, it will allow the AI to answer us with some actual data that we already have on these vectors, right? So this would be kind of the flow of the person interacting with the RAG system. First, the person asks a question through the chat, through this chat that we have here, right? Then an endpoint is created to communicate with the RAG system, it Express, and this will perform in-database similarity search of the vectors that were already there about the reviews of the products. So I want to just, as an example for you, I want to keep it simple. So I just created vectors that would represent, I will see the structure, but I'm creating the vectors that will represent like a summary of the reviews that people left on several products in the application. So through this similarity search, we will get the relevant context, or the 5 or 10 closest vectors that we can find based on the user's query, and we will return those. So imagine that, and this will entirely depend on the way that we structure the data. If we ask the vector database something like, what are the worst reviews on the application, it will try to find, those reviews on the application that have a similar feeling to the database in vector mode, closer to the word worst, which is the word in the prompt. And of course, you could tweak this and have it do more sophisticated things. But the main premise of vectors is just computing the distance very easily, just like subtracting two vectors, like Beta said. We will be using, and just for your information, a mini LM embedding model for this problem, which I believe has 350 or around 380 values in the vector. Just for your information, every review is going to be converted into a vector of 382 or 380 values that represent the meaning of the review numerically for the computer, right? So there are some prerequisites to create this. First of all, you need some data, right? So the main focus of this is that you already have some, you already completed the previous session where we do the setup of the autonomous database. We connect to it. We perform the migration with Mongo Restore and Mongo Dump, and then we do already get access to this, which is our autonomous database with all the products and the reviews and stuff. And this is what's currently running in our application, right? So, I mean, everything that we see here is already running on Autonomous. So let me show you the structure of the reviews, which is what I'm kind of focused on, right? So, and this, you'll see that it already has embeddings here. So there are some Python scripts here that are mentioned on this guide that allow you to, create embeddings. And these are the 380 something values that I was mentioning. At the moment, I have this kind of like semi-automatic system that will go into the reviews periodically, every 24 hours, and it will check for new reviews. If there are any reviews without embeddings, it will embed the reviews and update this JSON value. Because remember, we're working directly with JSON native collection. So once the embeddings are created, and of course you could also do this with in database if you wanted, but I want to automate as much as possible because this has to be kind of like a semi-automatic system for the AI to work, right? Or within our app. So once we have this kind of system, I want to show you that once we vectorize this, and of course we are doing like an aggregate. Let me see if I can find where. But what we are essentially doing is appending the title of the review plus whether it's recommended or not, plus the rating, plus the review text. And this gives us the vector that we were mentioning, right? So we also combine that with Olama. So Olama, which is what you see here, is an inference framework that allows us to deploy large language models wherever we want. So what we did on this problem is structure the architecture kind of like this. On one hand, you have the MERN app already working with Oracle DB or Oracle 23AI already. And the flow of the application would be something like this. The user makes an API call to the chat endpoint, or to the RAG endpoint that we have. And then the RAG service, which is implemented in Python. I did implement it in Python because I don't like Node.js as much. We'll make an API call to Olama, which is currently running on a GPU compute in OCI. And once it makes this request, which we'll see the structure, and I think the structure of the query and the way that you present the data to the LLM is actually crucial. You will receive a response, and this response you will, just return to the user in some way. And you have to enable an express API endpoint so that the application knows that when you are, chatting with this chat, you actually want to access the RAG functionality. And that's it. We're doing vector similarity search with the database, like I said. And there are lots of files here that are useful. For example, if you don't have enough reviews because you are just casually browsing through this guide, then you do have this review collection sync that I created that allows you to create synthetically or fake reviews for the products that you already have on your database. So once we run this, we will get some kind of system with 100 reviews. I think I have 120 or something like that. But I do have a lot of them. And this is one of the important parts, right? That you do have an update. But let me just keep it simple and go back here and show you what is kind of required to implement the whole thing, right? So for the front end, we would need just this very simple chat interface So just a message display area for us to type, an input field, and a send button. And this is associated, I could show you in the code, but I don't want to get too much into the front end because it's not my strong suit. So what are the benefits of just implementing this with this minimal approach? Is that you will make minimal UI changes, which is perfect for me. It's very easy to maintain and extend, especially because it's implemented like a microservice. And we can integrate many other ideas that we have in this way. When I was fiddling with the application, I also tried to create this admin DB panel to check the connectivity between the databases when I was developing the first solution. Then what about the microservices? Well, and let me show you. But there is here we do have the application, right? And let me find it. Here it is. So on the LLM chat JavaScript, which is just a way to implement a connection to the database and a way to make a request to an Olama URL, right? So it's a very simple implementation where create some RAG endpoint so that the Express endpoint knows that what we are doing is communicating with the RAG system. And yeah, no, not much more. Things that are important is that since we are working with the standard or native JSON collections in the database, I decided to use a library that I do like a lot, which is called Soda. And I'd like to talk a little bit about Soda. But Soda is simple Oracle document access. And it's specifically interesting for working directly with the JSON or native JSON collections, right? So I created like an interface to interact with these JSON objects, so a way to list connections, insert, edit, update, find documents, etc., etc. So this is just like an interface to talk directly with the document, right? But it has a lot of built-in functions that allows you to query by key, which is in our case for the reviews good enough because we do have a review ID. So apart from having this Soda library, it does have built-in support for embeddings and for similarity search, which is especially interesting for us. So let me show you what we did for that. Because there is also this Oracle vector store here that acts like kind of like a middleman between the Soda utils application or the Soda utils implementation that I created to run similarity search. So when we get a query, we just connect to the database. We can select however many vectors or similar vectors we want. And if we go into this Soda utils, let me show you the code. But the Soda utils similarity search. So, and you'll see that here you can change this is the Euclidean distance algorithm. So if you want, you can also modify the algorithm that you want to use to calculate the vectors. Also, depending on the problem that you use, a different vector search algorithm might yield you different results. So this is something to consider. But this is how similarity search is implemented anywhere in the world. You find the embeddings, first of all. Well, you vectorize the user's input, right? So the user's query, you create the embedding, and then you compare this embedding, this 380 vector value vector, and you compare it to all the other 380 value vectors that were already on your database. So for all the documents, or for all the documents in the database, if it has an embedding, it will calculate the Euclidean distance between this embedding and the other embeddings for all the embeddings in the list or in the vector, right? So after the distance is computed, then just sort by the lowest number, which means that the vectors are the most similar. And then you can also attach some additional metadata just for you, for traceability purposes. If you are trying to implement something a little bit different, you might need some sources. So if you are, for example, citing a document, or the vector was extracted from a PDF file that has 25 pages, and then you might want to save the page number and the PDF name or the PDF title, so you can reference, oh, this vector is actually coming from PDF page 24. So yeah, this code will be available, so it will be available. You'll be able to edit however you want. But this is a very easy and straight to the point way to communicate with a simple Oracle document access framework, which I love and I've been using for a very long time. Right. And yeah, after doing similarity search, let's see here. After doing everything, we just have to associated the endpoints for Express with the RAG endpoint to this chat, right? So if let me make an example. So if we make an example like, can I get some great product reviews on the chat? So, and I'll show you what's actually going on in the backend. Of course, remember that many of these reviews were synthetically generated, so you might see that some of them do not make sense. Like, for example, someone that says, would buy again, but then put a 1 out of 5 there. It's just because it's random. But let me show you what's going on here. So, and this actually makes sense if I show you the prompt. So let me go to the prompt. Let me just find it. Pretty cool. If not, I will just show you on the terminal. Let me reshare my screen so you can see what's going on the terminal. Right. So this is my application running, right? So it has the MERN application running. I'm finding documents, it's making simple CRUD requests. And then I do have here my microservice running, which I'll show you is simply a Ubicorn RAG API. So I'm associating the Python script that I created to implement this microservice. I'm exporting it to the internet on port 8000. So this is the URI or the URL that I have to give the Express endpoint. My personal URL, in this case, since everything is running on localhost, I can just say localhost port 8000 to communicate with it, right? And then when I get a request, and let's go to the request that we just created, can I get some great product reviews from the shop? It's actually, on the first step, it's retrieving all the documents from the vector store using Soda. It searched for just 5, and this is, of course, customizable. But after embedding the original query into 384 values in one vector. It retrieves all the documents that I can find, and it displays them and finds the five most similar reviews available. Then it will retrieve them, of course, using similarity search, the Euclidean distance in this case, and it will build the context from it. So it adds the context and it sends it to the distributed RAG system. So for the distributed RAG, it does use, or it shall use, the original user's query plus all the vectors that we gave it, right? So it's not like we are just giving it, random information, or we are asking it to hallucinate. We are saying, well, actually, we want the information to be accurate with what's already here on the database, right? And finally, it builds the prompt and returns it to the user, which is what we were doing. Let me go back to. And, you'll be able to test this out once we publish. You can use our code. You'll be able to use our code, generate reviews if you need and stuff. And there is a detailed guide on how I implemented each part, right? So the microservice is running, and then you also get where these files are, how they were changed and implemented, how each part was implemented as well, right? So if you're interested in the front end, how this application actually is using Express to actually use as a redirect for Python. So how to communicate both languages, how to do distributed RAG, which is a very new concept, because usually, one of the main concepts of having the RAG system apart from the MERN application is that you can actually offload all the AI work to GPUs if you want it, without having to worry about the system being overloaded by having an additional functionality. And artificial intelligence usually does require GPUs. So the more modularity and isolation that you have between components, the better your application will work. And actually, it also gives you other benefits, like being able to distribute the workloads with other Python libraries to just, if you have too many AI requests, you can just offload them in a distributed manner between several GPUs if you want, without doing anything else to the application. So this is how easy it is to implement. You just need to create an endpoint, some front end, and the backend. And this is the way that I chose. But if you wanted to implement the RAG API or the RAG endpoint with Go, Ruby, any other language, you could also do that, right? And then I also provide you with some test scripts. So if you want to see how everything is running, right, you can trace back what are the 5 most positive reviews for the product, and you can inspect, for example, the RAG query. If you're, especially interested about each part, then I do have this main.py file here for that. But yeah, I think, I hope that this was informative for you. This demo. Just keeping it simple and following this structure to maximize isolation and iteration between the dev teams in an organization. And with this, the demo is concluded. Would you like to say anything else, Vega?
Yeah, so one question. So from the database point of view, you created like a vector index to get the performance straight, right? So I just want to make sure everyone understand what role the database plays here. And this is not only like storing the data, but also allowing you fast access to it, right? So Maybe I
Yeah,
missed
yeah,
this part, but you somewhere have created like really this vector index, right?
yeah. I mean, do you want to say anything specific about vector indexes? How they, because when working, and that is also a question that I might have. When working with JSON documents, um, the performance capabilities of having indexes is quite different to having like nested kinds of data, right? So depending on the data that you use, you might find indexing more useful than in other cases. But
Hmm.
23i is automatically, or I mean, I'll say self-indexing data, right?
Well, it still makes sense to understand the concept and make sure that indexes are being used if it makes sense, right? So you can also, I guess, look at explain plans and see if indexes are being used. My whole point was just to make sure people understand that vectors is just another data type in the database, and if you are experienced with Oracle, it should be straightforward to kind of see if the plan is good by using an index, etc. So because a lot of it also depends on where you where you run the embedding models, right? Where you create the vectors. Do you do it outside, which is in some cases better? Do you run it inside, so it's less moving parts?
Yeah.
Um, I think what
And
is the easiest things if someone wants to try this out? They would go to GitHub and clone your repository, and they would just run it, or how could someone
yeah. Well, at the moment we're in the process of publishing this repo. So this repo is at the
yeah,
moment private, but
yeah.
it will be public at some point. So you can check out the
Okay,
the Oracle devel, or if you're interested, because that
got it.
will be where it will be
Yeah.
published in the end.
Yeah, so Tara, do we have any questions? Yeah, go ahead.
Yeah. So during the demo, there was a question, what is the difference between Soda and MongoDB API?
Yeah, I can take that one. So I think at some point, not sure you have mentioned that you wrote something with SODA, Simple Oracle Document Access. This is
Yeah.
just one of the many APIs we support. It's kind of like a MongoDB API, but it's not using MongoDB provided driver, but Oracle actually provides these drivers. And if you work with Oracle database and you want it to serve these document use cases, you have a choice of APIs you can use. There's like these MongoDB. Actually, the Mongo API relies on Soda collection. So Soda is a way how we store JSON documents in Oracle database. We have like these tables called JSON collection tables, which are basically just regular tables. You can also query them with SQL, but we allow you this access where you don't view your data as rows and columns, but instead as documents. And that is called Soda. And there's one layer on top where it's basically MongoDB compatible. So what does it mean? You can use MongoDB's drivers for all the various languages. You can use Oracle direct Soda drivers for Python or Node.js or C or Java, whatever. And there's also REST access. So Soda is just one more API to access to work with your data. It has like these. Do you see this in line 230 where it says get ID, etc.? So this is like a get operation, and there's like find operations and delete operations, etc. So it looks pretty much like a MongoDB line of code, but it's using an Oracle Soda driver.
Yeah. I mean, especially for me, this was particularly useful because I was always working with JSON. So it's almost the same as working with JSON
Yeah.
documents on Python. I would say with additional capabilities, like you can also find documents by key,
Yeah.
um, and update by key and stuff. But it's like
Right.
yeah, like
Yeah.
I
So
don't
not
want to
sure. I
say
think. Yeah.
it's a better way of using JSON. Yeah.
Yeah. Nacho, there is a question here. Can you explain how you loaded the vectors in the database? So I think that can you maybe repeat that part, how you got the vectors in the database?
Right, right. So there are two parts for that. Part number one is making sure that all the vectors do have embeddings, right? So, of course, how they arrived there was with this Soda utils
Mhm.
Python implementation that I showed, right?
So
So
you built the vectors
once,
outside the database, right?
yeah,
Okay.
with an embedding model that's also outside the database.
Yes.
But I haven't mentioned that inside the database, you also have embedding models. You
Mhm.
can also chat with LLMs because we do
Yeah.
have a way to authenticate against OpenAI, Cohere, or our own OCI generative AI service.
Yeah.
So you can do anything that I did.
We can even run
Also,
like some models like the Onyx models directly inside the database, right? You don't even have to
yeah,
make any call outside. I think the main message here, like really high level, is you can build the vectors, run the embedding models inside the database or outside the database. Now,
yeah,
what most people do is they run it outside the database just because building the vectors is very CPU intensive. And it's also easier to run these on GPUs. And a database server usually does not have GPUs. If you start using database CPU to build your vectors, you will end up with the same result, but you use database CPU for that. So that might be fine in many cases. For example, if you don't have that many documents that you're inserting or updating, or if you have a very powerful server, but in other cases, it might just be faster or cheaper or more scalable if you use an external a vector creator embedding model.
yeah. I mean, as long as you stay consistent with which
Yeah.
embedding model do you use, because if you use one for embedding and then another
Right.
one for doing the vector similarity search, it might break stuff for you. But if you stay consistent, you can choose
Yeah.
without
Mhm. So I
without
think the
repercussion.
high level, it's again like, do you want fewer moving pieces? Then you use everything inside the database. That is a simpler architecture. Or do you say you want to scale your database independently of the thing that builds your vector? Then you would build the vectors outside. Maybe you get new documents in batches, and you don't want, if you run this batch, you don't want your other database operation to slow down. That would be a reason to build the vectors outside. But regardless, they will be stored inside the database. They will be indexed by the database, and they will be used for distance search there. Let me just share the recap slides here because
Mhm.
we're approaching the end. So what we've seen, and we can answer questions in a second, we can continue. What we've basically seen, if we summarize what we have shown in these two sessions, that it's really very forward or very easy to switch from an application that was written for MongoDB, switch it to Oracle with, I think you literally just replaced the connect string and your app ran. Some cases you may have some queries that you want to optimize for Oracle, etc. But it's usually very straightforward. This is why we kind of stopped calling it a migration and we really call it like a just a switch, and it's quite cost effective. I know we got a lot of developers on the call. They may not care that much about such a switch lowering their bill significantly, but especially for I think especially in these AI times where IT divisions want to free up budget to run AI project, it's actually quite an interesting move where you say, hey, I have all these applications that I run and that I want to keep running, and with minimal amount of work, I can free budget for more interesting projects. I think this is another good reason to really consider applying Oracle here. And what we've seen today is that this switch not only keeps the existing app running as is, in most cases, the app was not really written for AI, but because it's been moved to Oracle, now this opens the opportunity to leverage all the AI capabilities that exist in Oracle database. I think a nutshell, one thing we should also emphasize, and we could consider adding it to the demo, is that it's not only about similarity search. So you had this example about the video. I think you said it's like faces, happy or crying. And for such a use case where you have many videos, you would probably not store the videos in Oracle database, but you could create JSON documents with the metadata, right? what is the location of the video, what is the title, when it was added, and then the vector that describes the semantics. But you could also add more data to it, right? You could say, what's the location? What is the time? Like in what I don't know if it's like places where events happen, like what was the place where this happened. And then you could have queries, not only on similarity, but also on these other fields. So you can have queries that say, hey, I want to look for sequences that look like this, or a photo that like extract the vector of a photo and see if you find it in a video. But at the same time, I want you to check if this happened like in the last week and in region XYZ. So Oracle Database Optimizer is smart enough to run a query efficiently if it has some part, let's say it's a spatial portion. Another part is a like a simple B-tree lookup for a date range, for example, and another part is a similarity search, which benefits from a vector search. So I think that's another very important thing to understand, that with Oracle Database, it's not similarity vector or this or that. You can really combine these things, and stuff works together. I don't know. Do we have any more questions, Tara?
Let's see. Um, there was one other one that had been during the demo as well that was just about our vectors in JSON, just JSON arrays.
Oh, that's a good one. I like that. Someone really pays attention. I mean, it looks like this. Um, if you print, I mean, we don't, if we store a JSON, we do not store JSON text. So we use a binary format, and so does MongoDB. MongoDB's format is called bson. Ours is called osin. And when we show you that binary instance, it wouldn't help you if we would show you the bytes. So this is when we kind of convert it back to a text, and this is what's shown in all these tools. So it looks like a text. And therefore the vector is being printed or serialized as an array, but under the covers, it's actually its own data type, which is optimized for fast access. Because usually with a vector, like unlike an array, where you access different parts of the array, like where you have random access, with a vector, you kind of treat it as one value, as one scalar value. And that's what we optimized our OSINT format to, that if you have a vector, like an embedding, it's optimized for fast retrieval and fast similarity search. So it's not an array, although if you print it, you couldn't tell that really.
If I could just add a final point, I think one of the interesting things here is the openness of what we're actually allowing people to do. So I think to some extent, gone is the old Oracle where you had to choose the Oracle way of doing things. Now you can choose almost any way of being able to interact with your data and any data format once you're in the database. And so if you want to store documents alongside graph data, alongside images, alongside anything else, you can do that. And you can mix and match your APIs. You could use Mongo API against your collections, but you can also run SQL against those collections. So there's much more flexibility in the modern Oracle than there was in the past. And I think that's a dramatic change for us. I think the Mongo API compatibility is a fantastic step forward in supporting those alternative standards.
Great final works. Okay. Thanks a lot, everyone.
Thank you, everyone. Just to wrap up here really quickly, if you enjoyed today's session, I have just dropped into the chat where you can find upcoming webinars. That's just at oracle.com/developer/events. So thank you again so much for joining us here today, and we hope to see you at the next one. Thanks.
Thank you.